Hey guys, it's Paul. Welcome to Where Nerdy is Cool, and meet my little friend, the world's largest 3D printer. It's out here cranking a print away, and today we had a lot of festivities. We revealed the big world's largest 3D printer and two of the largest 3D prints. All kinds of stuff to show you. Are you ready? That's really close. Here we go.
Hello YouTube! Welcome to my channel where nerdy is cool. My name is Paul. If you're not already a subscriber, please hit the button down below and become one. I don't want you to miss any of my cool videos. If you're already a subscriber, welcome back. Let's move on. So a lot to talk about in this video. This is kind of future Paul right here. I took a lot of video yesterday of the unveiling of the world's largest 3D printer, and to be clear, that is a polymer printer. I know there are bigger printers or big printers like that do cement. We've seen them in China and other places, so let's quash that comment right away. I'm sure they'll be in the comment section anyway. But just a full disclaimer that I do work for the University of Maine Advanced Structures and Composites Center. I've been there since August. It's been an amazing adventure so far, and when I was hired, I got to be sent out with the team to the Ingersoll plant to learn how to use this big printer. So I just want to give you that disclaimer up front. So if I sound like I have any kind of bias or I'm really excited about this thing, I do have a lot of pride in this because I work there, and we're trying to innovate and bring this technology to more industries to make it more useful to them. So that said, what happened yesterday? So where I work, we decided to 3D print a boat. We printed it out of carbon fiber ABS, and it is now based on the Guinness Book of World Records. Not only do we have the world's largest polymer 3D printer, but we have the largest 3D printed boat at roughly 25 feet and I believe 5,000 pounds. And that also makes it the largest solid 3D printed item. So there you go. Now, some more details here. We've at the center, we've also printed a bridge support, and we've also done it looks like a command center, and I'm going to talk about that and interview my boss. James Anderson is going to give you all the details on the printer. We're also going to show you some clips of the actual event, the unveiling. We had a lot of VIPs at the center. We had I'm up here in Maine, so we had Senator Susan Collins, Senator Angus King. We had one of our congressional representatives, Jared Golden, and various other VIPs, the president of the college, and so on. So without further ado, let me roll some clips here. And like I said, this is a 3D printing channel, so those of you that are huge into 3D printing are definitely going to want to hear the specs on the printer that I'm going to roll here in a second. And to those of you who are interested in the largest 3D printer but may not understand some of the things we're talking about, that's okay. Cruise right along. I think you're going to find this video to be very cool.
This is a big deal. This is probably the biggest day for this university since Stephen King matriculated in 1965. We are present at the unveiling and development and initiation of world-changing technology. I mean, I'm not kidding. Can you imagine being able to tell your grandchildren, I was there when they invented the hammer? This is in that same category. This is going to change everything. 3D printing is a revolution in manufacturing in every way. In the military, for example, one of our problems is spare parts. We have a problem with aircraft that are these incredibly complicated, expensive aircraft that can't fly because they lack a part. In the future, there's going to be a little perhaps not this size, but a 3D printer in every hangar of the Air Force, and if they need a part, they can print it that day.
On your mark, go. It's unveiled 3 years ago. Congratulations.
So the print volume is 60 feet long by 22 feet wide by 10 feet tall. The extruder is currently set up to feed about 120 pounds of material per hour, but the machine is capable of feeding up to 500 pounds per hour with a bigger extruder. Right now it's set up with a 0.4 inch or 10 millimeter nozzle, and the bead size that it prints out is half an inch or 12.5 millimeters by 0.2 inches thick, so 5 millimeters thick.
Wow. Okay, and the materials that you're using right now?
Right now we've been using PLA, wood-filled PLA, which is the material we've developed here, and carbon ABS, because that's been commonly used in the large-scale printing, but we could print almost any thermoplastic on the machine. Well, I come from a boat building background, and boats seem like an obvious choice for large-scale printing. A lot of boats are already plastic. I mean, cars typically aren't plastic. Airplanes are a bit too high-tech and highly loaded, but boats make a lot of sense. They're large, they're complex shape, but they're not hugely highly loaded unless they're very fast boats. So they're already made of wood or composites. So it seemed an obvious choice to me as an engineer who's designed a lot of boats that boats should be printable.
So let's talk about the bolt print. So how long did that take, and anything we learned from printing that we might do differently, or?
Sure, we took the boat was an existing design from a client of ours called Navitec, who designs high-tech boats. So they had a design, we had to tweak it a little bit to make it printable. We printed it using a 45-degree printing technique that we've developed here on large-scale printers. The print took 70 hours to print, used about 5,000 pounds of carbon ABS, and we learned that it went pretty well. There's some things we do a bit differently. The controlling layer time is quite important, so the slicer can't actually control that very well, but layer time is very critical for large-scale printing to get good bead adhesion. You want it not too hot and not too cold, so you want to control the layer time within a certain tolerance. So having that automatically calculated by the slicer would be great. Right now it's not, it's kind of done manually. You sort of tweak it as you go through the print, which isn't ideal.
So on a printer of this size, we're not worried about part cooling fans, we're worried about trying to maintain the heat.
Yeah, the bead holds, because the bead's so big, it holds the heat, and you want it to for a certain amount of time, because you're also printing large items, so it takes a while to get all the way back around to where you started again. In the future we might put some cooling on there so we can print faster and faster. Right now we typically work with between a 1.5 minute and a 4 minute layer time with carbon ABS. It's different for different materials.
So we've got the boat, we've got and you also did a shelter, and talk about that a little bit.
We do a lot of work with the Army, in a particular branch down in Massachusetts that deals with shelters. So I can't talk too much about that work, but they asked us to print a demonstration shelter. This was sort of shelter that goes, it's a little command post that goes on the back of an Army truck. That was about a 2,000 pound print. It took about 40 hours to print. Well, interestingly, large 3D printing has different opportunities and different weaknesses compared to small 3D printing. So bridging is not an option. The bead's so big, so heavy, and holds so much heat, it just sags. On small printing, you can bridge 5 inches if you really want to, if your cooling's dead on. Small printing, you can't really, on the small scale printing, you can bridge a long way. On the large scale printing, you can't really bridge more than an inch or so, because it just the bead's got so much weight to it and so much thermal mass that it doesn't cool down quick enough. So infill isn't really an option. So a lot of these things we're doing now, I mean, infill has been used a bit, but a lot of what we're doing now is sort of perimeters. So the boat, we're just printing the shell and a couple of internal ribs, which are hard to model with the size of technology we have now, and that complicates things. So we also, you know, the 45-degree overhang is pretty strict. You can really push that quite a lot further on the small printers, again, because of the cooling. But on the large printing, that's tough, because the bead has so much mass. We haven't had the printer very long. We're able to push the envelope a little bit, but yeah, there's a lot we can do. We're going to be doing a lot of work with our federal sponsors and local boat builders. But I welcome dialogue with a lot of the folks on YouTube who I've watched a lot of their channels. there's some very smart people out there, and I'd love to collaborate with some of them. But, you know, maybe get them up here and talk to us and see how we can work together.
Awesome. And if they want to reach you, the best way?
You can put my contact details in the link below, as they say. Where is it, down here?
Very good. So there it is, the world's largest 3D printer, the world's largest 3D printed object, and the world's, well, it's 3D printed boat. As you can see, it was sitting there in the wave tank, and we actually had people on board. So how cool is that? So I thank you guys for watching my video. Remember, you can find me on social media, Facebook, where Nerdy is Cool, Instagram, where Nerdy is Cool, and of course the website, where nerdyiscool.com. And of course I'm out there on Twitter as well too. You'll see that flag here. So thanks for watching. Again, if you're not a subscriber already, become one. And if you like the video, give me a thumbs up. And feel free to drop a comment in the comment section. I'll try to respond. So thanks for watching, and remember, this is where Nerdy is Cool.